This is USACO Problem 2018 December Contest Silver, called Convention. Farmer John is hosting a new bovine grass-eating convention at his farm. Cows from all over the world are arriving at the local airport to attend the convention and eat grass. Specifically, there are N cows arriving at the airport, and N is less than or equal to 10 to the power of 5. And cow I arrives at time T is less than 10 to the power of 9. Farmer John has arranged M, and M is less than or equal to 10 to the power of 5 buses to transport the cows from the airport. Each bus can hold up to C cows in it. Farmer John is waiting with the buses at the airport and would like to assign the arriving cows to the buses. A bus can leave at the time when the last cow on it arrives. Farmer John wants to be a good host and does not want to keep the arriving cows waiting at the airport too long. What is the smallest possible value of the maximum waiting time of one arriving cow if Farmer John coordinates his buses optimally? A cow's waiting time is the difference between her arrival time and the departure of her assigned bus. And we can test this out in the sample input. There are 6 cows. The first one arrives at time 1, second one at time 1, and third one at time 10, fourth one at time 14, fifth one at time 4, and sixth one at time 3. There are three buses, and each bus can hold 2 cows. And let's see now. There are 2 buses. Let's say these are buses. 3 buses. Cow 1 arrives at the airport, and she boards the first bus. She boards the first bus. The second one arrives and boards the second bus. Now this bus can go to Farmer John's farm, so the first bus is gone. And for both of these, the waiting time was 0 because they arrive at the same time, immediately board the bus, and then leave. So for the waiting time currently is 0. Then cow number 6 arrives and boards the bus. Then number 5 arrives and boards the bus. The maximum waiting time here is 1 because after number 3 arrived, it had to wait one time unit before the next one arrived. Now that one's over. Now at time 10, number 3 arrives, and then number 4. And for this, the waiting time would be 4 because after the first cow arrived at time 10, the next one arrived at time 14. So the first one had to wait 4 seconds. So the maximum waiting time is 4. And a way to solve this is using binary search. If we check for every single waiting time that would be possible, it would be n squared, and since the inputs can go up to 10 to the power of 5, that would be 10 to the power of 10, which is way too much. And this is why we'll use binary search, which reduces the time to log n times n, which can actually fit in the time that we are provided. So after getting, I'm assuming for those of you watching, you're already familiar with binary search, and that is basically out of the possible values, checking the middle, and if it does work, then moving to the appropriate half, and then checking the middle, and then checking the middle, and then checking the middle until you come to a value that works. And by implementing binary search, we can make a function that checks whether a waiting time would work. For example, I could name it check with int waiting time, and what we could do is first check loop through the cows. And in the for loop we can see if previous cow, the time that the previous cow spent with the current cow exceeds the time limit. And if so, we'll create a new bus for the current cow and then reset the previous value to this. And then at the end, we can check how many buses we used and check that against the number of buses we actually have. And now let's get to the programming part. This is my code, and for the function init, or initialization, short for initialization, takes care of the input. Using buffered reader and print writer, takes care of the input and the output. It reads the integers n, m, and c, as well as the list of cows, and I stored it inside a priority queue because this data type can, first of all, hold duplicates, and second of all, can quickly, well, relatively quickly, return the smallest, or in other words, the integer with the highest priority in log n time. And I just added all of the cows into it, as well as keeping track of the max value of all the cows arriving time. This will be necessary later when we implement the binary search. So we set the low to 0 because at the best case scenario, no cow waits and all of them go straight to Farmer John's farm. And high is the maximum value minus the lowest value plus 1. This is because at the worst case scenario, the first cow has to wait all the way until the last cow to leave. And I just implemented the binary search mechanism, as well as a check method that checks if the middle value works. And we're going to set the high to middle minus 1 and low to middle plus 1 when check is inputted as true, because we want to check for a lower value if it does work and a higher value if it doesn't work. And what we did is, first we make a variable called previous, which keeps track of the previous cows so that we can compare
the waiting time. And we're gonna need to keep track of a variable called bus, since we gotta keep track of how many buses we're using to make sure this value works or not. And count is the number of cows currently inside one bus. And while a copy of the cows, because we want to keep using the priority queue, we don't want to delete all of the um, values inside it. While it's not empty, get the smallest cow, count plus plus, which means we're adding the cow to the bus. So the bus count, we're keeping track of the cows inside the bus. And either if the number of the cows inside the cow is exceeding the limit, or the current cow minus the previous cow, which means the waiting time is greater than the waiting time that we're checking for. First of all, we're using another bus, so we're adding one to the bus, as well as setting the previous cow to the current cow so that we can compare the waiting time later, and setting the number of cows in the bus to 1. And at the end, after we iterate through everything inside the array or the priority queue, we're gonna return, we're gonna compare the number of buses we used to the buses we were allotted. That means if we used more than m, it's gonna return false. And I have the input right here, so let's check if this worked. And it outputs 4, which was the output we needed to get. Now we can check this on the USACO website. Convention. Ooh, I forgot to change the output to make sure that we're outputting on the file, not system output. Make sure to close the out file. And it looks like we got everything correct.